Hello, children. How are you all? Yeah, I hope you all are fine. That's fantastic. That's really very fantastic. And hope that you are doing great so far. And it's really wonderful to start our new session today. And the topic of today's session is periodic table. Okay, so are you guys ready? Yeah, we get to know so many information about the periodic table today. Yeah, I am Ruchi, your chemistry tutor. Welcome you all in today's session. Okay, topic you know, that today's topic is periodic table. So before starting with the topic, I would like to tell you a few platforms that we have. One is our mic button, that is on and off option is there. You need to just off your mic in a whole session, but whenever it required, then you can on it. Okay. The next option is your video option. Obviously, in a whole entire session, you need to just on your video, but whenever it is required, you can just move it out, just off your video. Okay, but come back fast. Next is a chat box. Okay, we know that in a chat box we have to write so many things, but unnecessary. Don't write anything in a chat box. Whenever you want to ask anything from the ma'am, then obviously you can write your query in a chat box. Okay, uh, I will definitely acknowledge it and will try to solve that. Fine. I usually speak in Hindi and English in my session, so guys, you don't no need to get worried. If you want to ask any question in Hindi, so I will definitely help you out in Hindi. Okay, one option is there is a troubleshoot option. Whenever in your like video there is creating a kind of problem, so we are having a technical team, they can sort it out your issue, so no need to get worried about that. So let's start today's session, and just I would like to boost up your energy with a positive energy. Just start today's session. Fine. So now tell me one thing. I know that you are all are very brilliant students. Now tell me, have you ever saw your cupboard in a day? Anytime have you ever saw your cupboard? Yeah, in your cupboard means where the clothes get arranged. Okay, now tell me now tell me, you can write your answer in a chat box. Tell me fast that is it really that you are supposed to arrange your cupboard daily or once in a week, but only you? Just write yes or no in a chat box. Yes, ma'am. So I will definitely understand that you guys doing a great job. Yeah, that's fantastic. Good answers. I'm coming. Very nice. Very good. Fantastic. I really appreciate your responses, students. That's really fine. Very good that you all are doing a good job and helping your mama in the work, that you are arranging your cupboard. That means after arrangement of the cupboard means clothes are arranged in a proper way. Fine. Then what do you feel? Obviously we're feeling a very good, right? If you want to just pick it the socks, if you want to just pick the shirt, just trouser, so it's feeling our comfort na, a comfort level is very good. So the same thing we are supposed to study in our periodic table. Okay, periodic table is nothing here, it is a human instinct to classify, means put things of one kind in one group and another kinds into another group. So that is basically a periodic table. That's why I just introduce a kind of example in starting, that how many of you used to set your covers in your way daily or once in a week. So I got a very good responses from your side. You guys are really very nice. If you are doing such kind of work, means helping your mama in day-to-day activity, it's really fantastic and it's really appreciating. Fine. So here in the same periodic table, we have means to put the things of one kind in one group and another kinds in another group. So the reasons for their classification, why we need such kind of classification, that we need to put this element in this group or this element in this, why we are doing such kind of study. Okay, so it helps in studying the element in an organized way. Means when we used to organize the things, suppose when we used to organize the things in a very good manner. So obviously means after organizing the cupboard in a good way, what happened? You guys feeling relaxed? You guys a kind of positivity generates. Yeah, so the same thing in the periodic table also. It helps in correlating the properties of the elements with the fundamental properties of all the states of matter. Yeah, so that's why the periodic table needs a kind of classification. But in starting, what happened? There are previous, means right now we are having what type of periodic table? I want answer. It's a poll question we have. So okay, now tell me that which periodic table we are using nowadays. Write your answers in the chat box. Yes, very nice responses. I really appreciate you all. A good thumbs up for you guys. Yeah, it's a modern periodic table. Okay. So in today's we are having a modern periodic table, but before proceeding with this modern periodic table, ancient, since from the ancient time there are so many kinds of periodic tables, so many scientists gave their views and they performed, and drawbacks came, and they due to such kind of drawbacks the kind of periodic table get failed, and finally we get modern periodic table. Okay, in this modern periodic table what we have means a kind of symmetry is there. All the elements are placed in a very good manner, right? They are placed in a very good manner with having a same properties, means the element means the element in the same group, they are having a same properties, they're having a same react all the physical and chemical properties. So this makes a soothing way, means in today's periodic table, that is a modern periodic table. Okay, so let's start with our previous periodic table also, because we have to know that what kind of classifications we have, means how many types of periodic tables we have, because definitely this type of questions obviously asking in the exam also, that what kind of periodic tables we have previously. Fine. So let's start the approaches of the periodic classification of the element. If you guys want, because if you guys want to write it, definitely as we are in a senior class, so we have a pen with us all the time, means when we are studying. Fine, means anything you can grab it, that is good for you, you can just hit write in your notepad. This is a suggestion from myself. I hope that you will definitely follow it. That's fine. Thank you so much. Thank you. So the first one is Daubernier's triads method. What was that? Here, Daubernier's classified the element with similar chemical properties into groups of three. That's why it is called as triads. Triads. Okay. And he noted that the atomic weight of the middle element in a triad is the arithmetic mean of the other two. And this is called as Daubernier's law of triad. But once when this Daubernier's law came, then what happened? This Daubernier's law is totally failed. Why? The reasons of discarding of this law. Why? Because the Daubernier's, however, could not arrange all the known elements at that time in the form of triads. Okay. What was a triad? The triad was of combination of three elements, and that is lithium, sodium, and potassium. Okay, now tell me, I want answers from your side, that what is basically the atomic number of lithium? Write it down fast. Actually, I don't want a two-way communication in my class. As usual, I want to convey this message to you, a kind of two-way communication, two-way traffic, in order to in order to enhance the interest, because means it's not like just ma'am is speaking, you have to just listen. I'm not saying this thing. I want a kind of positive responses from your side also. Okay. So now tell me, very good. Your answers are coming in a chat box. The atomic number of lithium is obviously 3. So here, what is the reasons for discarding the laws of triad? Means this law the means they couldn't arrange all the known elements, means we can say triad in a proper way. Fine, and the law was not applicable even in a same family. That's why this law get discarded. Fine. Now come another scientist, and the name is Newland's law of octave. Okay, what is the Newland law of octave? According to him, the Newland proposes a octaves which state when elements are arranged in an increasing order of their atomic masses, then what happened? The properties of the eighth element are similar to the first. Again, the problem creates, means he wants to arrange the element in a proper way, but what happened? The properties get matched, means eighth element are just similar with the first one, and therefore this classification was known as the Newland octave. Octave means 8, like octopus, 8 legs. Okay, so eighth element are having a similar nature as of the first. Fine. So this Newland octave also having some merits and also having some demerits. What's that? This system worked well with the lighter elements. Means when we are talking about the lighter elements, they are not heavy lighter elements. Then like lithium, sodium, potassium, they are brought together. So then this octave is okay. Fine. But when we are talking about the heavy elements, it relates the properties of the element in a atomic masses. So for the heavy element, this octave not plays a very good role. It's not applicable for the heavy elements, like, okay, it is applicable only for the lighter elements. Fine. So this is the basic reason for discarding this Newland octave, and again this Newland octave get discarded because the classification could not be applied for the heavier element. This Newland octave only applied a kind of classification for the lighter elements like sodium, potassium, like all this. But like heavier element, we can say like calcium. So it creates a kind of problems in maintaining the elements in a row, groups, column. Means how can we arrange such kind of elements in a proper and systematic way? So due to this reason, this Newland octave again failed. Now the next periodic table come. Octave also gone. Then who comes? That is a Mendeleev periodic table. You guys just need to remind the names also. Mendeleev. By this way, like you can play with the name, like triad. You can just make a triad, and you can just make a octave. A kind of it will helps you in your memorization actually. So you can play a kind of games either in your home or in your friend circle in order to just memorize the names, because even I am thinking when I was a student, these kinds of name are quite difficult to understand. Fine, because the name as well, they are having a very different types of names. Okay, so this is again suggestion for you guys, just to try to memorize it by the same way what ma'am is saying to you. Okay, that's good. Fantastic. Now next is Mendeleev periodic table. What he says, the physical and chemical properties of the elements are the periodic functions of their atomic masses. As we are talking about the essential features of the Mendeleev periodic table, what Mendeleev said, then there are 8 vertical columns that are called as groups from 1 to 7. And all the elements of the subgroup have a similar properties and show having a same valency, which is equal to the group number. Now tell me fast, what is the valency? Yes, I hope that you guys know valency. Obviously, the combining capacity of the element, that is the valency. Yeah. And there are 7 horizontal rows that are called as periods. Fine. And they are numbered from 1 to 7, from left to right in a period. So these are certain features, essential features for the Mendeleev periodic table. And Mendeleev also gives like merits also, means positive factors for the Mendeleev periodic table, like grouping of the elements. Elements are grouped in a proper way, in a generalized way, customized way. Like gaps for undiscovered element, means those elements who are not still discovered, they are making a kind of gap. Okay, next, prediction of the properties of undiscovered elements, like those elements who are still not discovered, a kind of prediction, like sixth sense prediction. The Mendeleev was tried to give, like Eka boron and Eka aluminum. These are like undiscovered elements. So he used to predict their properties and all. And incorrect atomic masses was corrected with the help of this Mendeleev periodic table. Fine. So Mendeleev also plays really a very fantastic role, but there are some points also which makes failure of this Mendeleev periodic table, and this Mendeleev periodic table get failed. And last one is a modern periodic table that is going on. At present, we are using the modern periodic table. Fine. And what are the defects in the Mendeleev periodic table? Because there are some defects also in the Mendeleev periodic table. Anyone knows what is the meaning of defects? We can say, suppose you arranged a cupboard in a very good way. According to you, the cupboard is very nice and fantastic, but there are some errors also. Your mama come and told to you that Ayan, a kind of disturbance I am just showing in the cupboard, means this clothes should you have to just put at the above side, or this cloth you have to just segregate at the lower side, such kind of. So a defects came here in the Mendeleev periodic table. Fine. What are the defects? Like its anomalous behavior. Anomalous behavior like cobalt. Okay, cobalt with higher atomic mass, because the atomic mass of cobalt is really very high. Higher atomic mass proceeds with nickel in the periodic table. Like cobalt is having higher atomic mass and it proceeds with the nickel. Nickel is having lower atomic mass. Fine. So like with the error of all this, the exact place of the cobalt and nickel creates a kind of error in that. And position of the isotopes also one of the major defects in Mendeleev periodic table. Isotopes, you guys know? I hope so that you know the meaning of isotopes, having same atomic number. Yeah. So the isotopes of an element are the atoms of that element with the similar chemical properties but different atomic masses. And according to the Mendeleev periodic law, what happened? The isotopes of an element must be given separate places in the periodic table because they have different atomic masses. So this is really a big reasons for the defect of the Mendeleev periodic table. Fine. So this is the one of the defect in Mendeleev periodic table. Next defect we can say like electronic arrangements. Means it does not explain the electronic arrangements of the elements. Means what is the exactly electronic arrangements? Mendeleev don't able to just explain. Fine. And the position of hydrogen as well. Position of hydrogen. Hydrogen is at the top in the periodic table, and still the position for the position of the hydrogen the Mendeleev was still very confused. Very confused. The hydrogen was not find a fixed position. It was considered as a group 1A as well as in the group 7A because it forms a positive ions in the HCl as well as negative ions with the NaOH. Because in the first group, what we have in the first group? Alkali metal, and sodium belongs in the first group. That is a one of the good alkali metal. And in the seventh group, what we have? Fluorine, means halogens are there: fluorine, chlorine, bromine, iodine. So this is the basic reason that hydrogen is not giving is not given is fixed position. Means if hydrogen is supposed to placed in the alkali metal group or in a seventh group like halogen group. So it was quite confusing there. So these are certain defects that we read here for the Mendeleev periodic table. Okay, like Aryan, Neha, Karthik. I hope that you are getting my point. We are studying periodic table, and ma'am is giving you certain previous periodic tables. That why ma'am is giving you a classification of the periodic table here. That why such periodic tables have failed. What are the kinds of defects we realized, and they are just failed and get back to new periodic tables. So here we are studying. I hope that you are getting my point. That's very nice, fantastic. Just giving your positive responses, and just try to give more and more your interest in the study. I know that the students are like supposed to do that. I don't want to study and all this thing, but up your positivity, your boost energy, and especially your mentor like me are always forcing you to do study as well as possible, because the ma'am or teachers, we can say, are always boosting us, giving positive vibes to us, that when you are doing a good study, when you are scoring a good marks in your study, then what happened? Obviously your parents will get happy. Okay, so in order to get happy to your parents, you need to study very well. I hope so. Just show me your thumbs up fast, fast, fast. Show me it fast. That now that obviously you guys are very good, and doing a very fantastic job. But still, it's my job to, as a teacher, it's my job to just giving you suggestion. Just try to give more and more time in your study. Okay, because exams are coming. That's nice. Now let's move to our final periodic table, that is we have, that is a modern periodic table. Okay, and the in the modern periodic table, what is that? The physical and chemical properties of the elements are the periodic functions of their atomic number. Means on the basis of the atomic numbers, the elements get placed in the periodic table, and it's really very simple. Means on the basis of the like atomic number, they are placed in one group, two group, three group, four group, and so on. The modern periodic table contains 7 horizontal rows that are called as periods, and 18 vertical columns that are called as groups. Okay, so you need to just claim that how many rows we have in the modern periodic table, and how many like groups we have in a modern periodic table. Fine. Apart from the 7 rows, there are 2 additional rows also that place separately at the bottom of the table. Okay, and the entire table, is divided into 4 blocks. Any one of you can name the 4 blocks. You can also play a game with the name of these blocks, like S block, P block, D block, and F block. These names are all are also of our towers, like where we live. Our towers name are also like in a block A, B, C, D, E, F, like this. Okay, but here the in a modern periodic table only 4 blocks are there: S, P, D, and F. Only 4 blocks. And in the modern periodic table, what we have, that is also called as long form of periodic table, isn't it? And the fifth similar properties which recur after a regular interval are called periodic properties. Fine. I hope that you guys are doing great and fantastic. Now there are so anomalies in the like we have read anomalies in the Mendeleev periodic table, and there are some silent features of the modern periodic table, like groups is determined by the number of the electron present, and group 1, 2, and 13 to 17, they are called as normal elements. Okay, and group 3 to 12, they are called as transitional elements. Transitional elements like scandium, titanium, vanadium, chromium, manganese, cobalt, nickel. These are the transitional elements. And group 18 are extremely called as noble gases. Means in the group 18, what we have, inert gases and noble gases elements are placed basically. And what are inert gases and noble gases elements? They are completely stable. Their reactivity is 0 because they have completed their octet. Octet is totally completed in the noble gases and inert gases. That's why they are not reacting anymore with any element. That's why it is called as inert gases or noble gases. And the reactive elements are basically placed in the groups of 1A and 2A, means alkali metal and alkaline earth metal like sodium, potassium, rubidium. And in an alkaline earth metal, beryllium, calcium, magnesium, all these in the alkaline earth metal, and they are really very reactive. Like if you're talking about the periods, the horizontal row of the elements in the periodic table that are called as means horizontal row, means this is the vertical and this is the horizontal. So the horizontal rows are called as period and the vertical row are called as groups, and they're the 7 periods in the long form of periodic table. And the elements in a group have consecutive atomic number also. The first period contain 2 elements and is very short period, and the second period contain 8 elements and it is also really a very short period. Like this third period, fourth period, fifth period, like in the third period we are having 8 elements again. In the fourth period we are having 18 elements. In the fifth period we are having again 18 elements, and in the sixth period we are having 32 elements. And the seventh period contains remaining elements and is incomplete. Okay, so you need to just frame it out the periods also, type of the elements in the modern periodic table that we have, and it's really very interesting. Like you just open the periodic table in a Google form or in your textbooks also, yeah, in your classroom textbook also, or whatever we are providing you by juice video also, a kind of you can see na periodic table pictures. You just go through with the whole picture of the periodic table. Then what you see here, in the first group there are alkali metals are there, and second is alkaline earth metal. Transition series you get to know, noble gases and inert series you get to know, means you get to know so many things after showing a kind of periodic table in front of you. So definitely after the session, I hope so, because I'm pretty sure about this, that every one of you just open in a Google or in your textbook what we are providing to you, a kind of periodic table in front of you, and will definitely go through with it. Okay, just promise me. Yeah, that's very good. Fantastic. You all are really superb. Very nice. So what we have in the modern periodic table, there are like representative elements like S block and P blocks element. They are called as representative, like group 1, 2 and 13 to 17, all are the representative elements. And next is transitional elements. They are in the D block from group 3 to 12. They are in the D block. Okay. And inner transitional elements, again, they are in the F block elements. And inert gases and noble gases also, and their groups are called as zero groups. Why they are called as zero groups? Because they are in a 18th vertical column and their octet is completely full. That's why they are in a zero group. So there are so many merits also, means merits means certain good points also of like long form of periodic table that we have. And as per the periodic table, their reactivity also takes place, their electropositivity, their electronegative behavior, means when the elements are placed in a very good manner, in a very systematic manner, we can say, then after that we just go through in a process of like various features. What is the electropositivity, what is the electronegativity, means in the left side basically metals are there in the periodic table, and at the right side there are non-metals, and in the center metalloids are there. So always the metals are having more electropositivity, they have a tendency to lose the electrons. Metals are having a feature, whereas non-metals, they accept the electrons. Fine, electronegativity is there. So this is the basic one features which I am explaining you here. There are so many features: electropositivity, electron affinity, what is the boiling point, what is the melting point. These are the features of the element, like first group, second group, third group. And what is about the reactivity of the first group element, means reactivity, is the reactivity decreases from top to bottom, is the reactivity increases from top to bottom, anything from left to right. So all this study will proceed here in our modern periodic table. It is based on the atomic number, which is more fundamental compared to the atomic mass as well. The position of the elements in the table is related to their electronic configuration, and it shows a regular changes in the period, like properties of the various elements when moving across a period or down in a group. These are certain merits, these are certain positive points of our long periodic table. Fine. And there are, I hope that you guys are showing a kind of interest here. We have certain features also, like valency features also. What kind of valency we have means, valency means capability, yeah, in the outermost shell. In the outermost shell, how many electrons are there means, is it how many electrons we need to get share, or we need to just lose, all these things. Like atomic sizes, what is the atomic size means, how the atomic size is increasing, is it increasing from top to bottom, or is it decreasing from left to right? Everything we get to know in a modern periodic table. And one more thing I would like to tell you in a detailed concept. Fine. Definitely, I will come again with all the features of, like, which I have told you: atomic radius, electropositivity, electronegativity, how they will increase, what is the exact effect of the reactivity on the elements. Everything we will explain in detail. I will tell you in detail in our next class. Okay, so it's enough for today. I think we have read all the periodic table and their classification, and for the detailed process I will definitely take another class for this. And till then, you just go through with the Byju's videos also, and I know that you all are very fantastic, very nice, very confident, and very intelligent as well. Okay, so try to give more and more time on your studies, and I promise we'll meet you soon as possible. I will take another session. Till then, take care. Bye bye. Thank you so much.